Have you ever considered how closely connected Earth and space are? We usually think of them as two completely different areas, the world we live in below and the vastness of space above. But a recent discovery shows that the boundary between these two worlds is not as firm as we once thought. As it turns out, Earth's weather is more connected to space weather than we ever imagined. Just picture this. A lightning storm is happening in the sky, and you can hear the flash and crack echoing through the atmosphere. But what if I told you that the energy from that lightning bolt doesn't just stay in our atmosphere? It shoots up, radiating far beyond our world and even affecting the particles trapped around Earth. This isn't science fiction. It's a real phenomenon uncovered by researchers at the University of Colorado Boulder. Their groundbreaking study reveals that lightning storms on Earth can shake loose high-energy particles in space, triggering a cosmic chain reaction that can have serious consequences for astronauts, satellites, and even the atmosphere we depend on. The study was led by an ambitious undergraduate student named Max Feinland, who, along with a team of scientists, made an incredible discovery: a link between lightning on Earth and space radiation. By using satellite data, they found that lightning storms can affect killer electrons from the inner radiation belt. This is a region of space that's full of charged particles, like an invisible belt wrapped around our planet. These killer electrons might sound like something out of a sci-fi thriller, but they're very real and potentially dangerous. These high-energy particles can cause all sorts of problems in space. They can get into satellite hardware, damage electronic systems, and even pose a serious health risk to astronauts by increasing their exposure to harmful radiation. So how does a lightning strike here on Earth set off such a reaction way up in space? It's all down to radio waves. When lightning strikes, it produces bursts of energy that send radio waves shooting out in all directions. These radio waves can reach far beyond our atmosphere, where they encounter the charged particles of the radiation belts. It's like a cosmic pinball game. The radio waves smack into the electrons, knocking them loose from their place in the belt, causing them to careen around before they plunge toward Earth's atmosphere. This process, known as lightning-induced electron precipitation, can affect not only the space around Earth, but also the chemistry of our atmosphere itself. This might sound familiar if you've heard about space weather before. Space weather is the term used to describe the conditions in space that affect Earth. These are often driven by solar winds or geomagnetic storms from the sun. But this new discovery adds a whole new dimension to the story. It's becoming clear that Earth's weather can also have an impact on space, as well as just looking at how space weather affects Earth. To put it another way, what happens in space affects space weather, but it also influences what happens here on Earth. Lauren Bloom, an assistant professor at CU Boulder and a co-author of the study, explained that there are two main radiation belts around Earth. These are regions packed with charged particles that are trapped by Earth's magnetic field. These belts act as protective layers, shielding us from harmful solar radiation. The inner belt is closer to Earth, starting about 600 miles above the surface, while the outer belt stretches from around 12,000 miles above. These belts shift and change over time, but they serve as a kind of barrier between our planet and the harsh radiation of the solar system. At least, that's what we used to think. For years, scientists thought the inner radiation belt was pretty stable. It was thought to be a calm, predictable zone where the lower energy electrons, colder and less harmful, stayed put. But this new study shows that even the inner belt can have sudden surges of dangerous, high-energy electrons. These surges are caused by lightning storms here on Earth, which dislodge the particles and send them bouncing back and forth between the northern and southern hemispheres. Each time the particles ricochet, some of them fall out of the belt and rain down towards Earth. The researchers call this a kind of electron rain. This discovery challenges long-held assumptions about the inner belt. Up until now, scientists had only managed to detect lower energy electrons trickling out of this zone. But what Feinland and his team saw was completely different. While looking through data from NASA's Solar Anomalous and Magnetospheric Particle Explorer, or SAMPEX, satellite, which was in use from 1992 to 2012, Feinland noticed something strange. He saw groups of high-energy electrons in the inner belt, particles that weren't supposed to be there at all, according to existing scientific models. When Feinland first presented his findings to Lauren Bloom, she was taken aback. The data seemed to go against everything that was known about the inner radiation belt. The data showed that high-energy electrons shouldn't have been there, but they were. Of course, the team decided to look into it some more. They went back through years of satellite data and started comparing it with records of lightning strikes in North America. What they discovered was incredible. Many of the spikes in high-energy electrons occurred just moments after lightning storms on Earth. This realization was the start of a whole new way of thinking about how connected our planet is with the space environment around it. Every time a lightning bolt strikes, the resulting radio waves set off a chain reaction in space. These radio waves can jolt electrons in the radiation belt, sending them on a wild ride through Earth's magnetic field. The electrons ricochet between the poles in the blink of an eye, bouncing from the northern hemisphere to the southern hemisphere and back again. Each time they bounce, more electrons escape from the belt and rain down towards Earth, dissipating in the atmosphere. This discovery has some pretty far-reaching implications. It seems that space isn't as isolated from Earth's weather as we once thought. In fact, these findings suggest that what happens on Earth can affect space weather. And that's important because space weather isn't just an academic interest. It has real-world implications. The high-energy particles in space could pose a serious risk to astronauts on long-duration missions, like those planned for the Moon or Mars. Exposure to these particles could increase the risk of cancer and other health issues. Even satellites are vulnerable. If a satellite's systems are exposed to too many of these killer electrons, they could malfunction or even shut down entirely. The study's authors are optimistic that by gaining a better understanding of how lightning storms affect the radiation belts, we can develop new ways to predict and mitigate the risks posed by space weather. This could help us keep satellites working properly and make sure astronauts are safe during space missions. The more we understand about how Earth and space interact, the better we'll be at protecting our technology and people in space. One of the most interesting things about this discovery is how it challenges our idea of space as a cold, empty, and isolated place. It turns out that even the weather systems on Earth, something as familiar and everyday as a lightning storm, can affect the space environment. Earth's atmosphere and the space around it are connected in ways we're only just beginning to understand. And this connection could have a big impact on everything from satellite communications to space exploration. Needless to say, there's still a lot to learn. The team at CU Boulder is carrying on with their research to figure out how often these electron rain events happen and what conditions make them most likely to occur. Some evidence suggests that these events might be more common during periods of high solar activity, when the sun is particularly active and sending high-energy particles towards Earth. But there's still a lot more work to be done before scientists can be sure they can predict these events. For Max Feinland, this project has been an incredible journey into the unknown. As an undergraduate student, he never thought he'd make such a groundbreaking discovery. But by following the data, he and his team have gained new insights into the mysteries of space weather and how it's connected to our own planet. The research is still ongoing, but one thing is clear. There's a much stronger connection between space and Earth than we ever realized, and there's still so much more to uncover about this cosmic relationship. So the next time you see a lightning storm, remember that it's affecting more than just our planet. It's sending ripples through space, dislodging killer electrons and reminding us that the forces shaping our world are not confined to Earth alone. As we learn more about space weather, we're also learning more about how interconnected the universe really is.